The NS400, Honda's first medium-class two-stroke super sporty motorcycle, is packed with modern motorcycle technology developed through road racing. The fastest road-going motorcycles of today are road racing machines. With the NS500 factory racer, Honda was successful in world-famous 500cc class World GP road races during 1983 and 84. Through Honda's racing activities, our engineers have attained the pinnacle of motorcycle engineering, and their knowledge and experience have formed the basis for development of the NS400R. Each component of the NS400R was designed and developed to realize maximum total performance. That is, the sum of speed, acceleration, stability, maneuverability, and cornering performance. Let's take a close look at each of these components to see how they are designed to meet this performance target. The first thing you notice is the full fairing, aerodynamically designed to reduce air drag at high speeds for increased maximum speed. The fairing also helps to improve riding comfort and high-speed stability. Besides the fairing, the front fork leg covers, large side covers, and the rear seat cowl are also designed to reduce air drag. Look at the front and rear wheels. In order to lower the center of gravity of the machine and to achieve quick, responsive handling, small diameter wheels, 16-inch front and 17-inch rear, are employed. Mounted on new Comstar wheels resembling those of the NS500 Racer are V-rate tubeless tires with new tread patterns. These tires are designed to perform up to the maximum speed of the motorcycle, which is approximately 215 kilometers per hour. Other features include a Pro-Link rear suspension and a torque-reactive anti-drive control equipped front fork. Now let's take a look at the inside of the machine. The frame body is made of lightweight aluminum. This strong, lightweight frame body has been developed making full use of concepts learned through racing and computer-aided engineering design. The frame configuration is basically a classic double cradle type. One very modern advance is the use of side frame members which are slanted to connect the steering head and the rear swing arm pivot with a minimum distance. This allows maximum strength with minimum use of frame material. To assure production quality through reduction of welds, cast aluminum parts are used for the steering head and the swing arm pivot area. The swing arm is also made of highly rigid cast aluminum. Other parts of the frame body are made of highly rigid rectangular section aluminum pipe. The surfaces of the aluminum frame parts are anodized to prevent corrosion. Another new feature is the remote control rear damper preload adjuster. With the help of a hydraulic activation system, rear suspension adjustment can be carried out simply by turning the adjuster knob. The most impressive feature of the new NS400R is the all-new two-stroke engine. A very unique V3 configuration. Two cylinders are positioned horizontally to lower the center of gravity, and the center cylinder is vertically laid out to form a 90-degree V angle. There is one build-up type crankshaft having 3 crank pins in line. It is held in the horizontal split crankcase by 4 ball bearings. If the 3 cylinders were positioned in line, space would be needed for the 3 cylinders and their transfer ports. But because 2 cylinders are horizontally positioned, engine width is as narrow as a parallel twin. Such a narrow engine can be positioned low in the frame while assuring a sufficient banking angle. Being narrow also means less air drag. One distinguishing feature of the cylinders used in this engine is the so-called Nikasil coating provided on the aluminum cylinder bore instead of the more common cast iron cylinder liner. The Nikasil coating is an electronically applied nickel silicon carbide layer having very high wear resistance characteristics. Not only does the absence of cylinder liners make the engine lighter, thermal conductivity is improved, and the cylinder exhibits the same expansion rate as the piston, thus keeping piston to cylinder clearance to a minimum for maximum power output. Similar Nikasil-coated cylinders are used in the NS400R racer as well. Provided between the front and rear bank cylinders are newly developed slant draft-type carburetors. These carburetors are designed to simplify and shorten the intake air passage for high suction efficiency. The throttle valve is a unique rectangular type which induces higher venturi vacuum than the conventional cylindrical throttle valve and improves the throttle response of the engine. Another feature of this carburetor is the power jet for supplementing fuel under high throttle opening conditions to ensure an optimum air-fuel mixing rate. After passing through the carburetor, the air-fuel mixture is drawn into the crankcase through a large reed valve. A Honda-developed auto-controlled torque amplification chamber, or ATAC, is attached to the 2 horizontal cylinders to improve power output characteristics. The auxiliary chambers are opened and closed electrically according to the engine RPM. For the NS400R, the valves are activated at 7,500 RPM. Below this level, valves are opened to use pressure pulsation from the auxiliary chamber to maintain optimum charging efficiency. Above 7,500 RPM, valves are closed to use the pressure pulsation created by the main exhaust chamber for high power output in the high RPM range. The ATAC control system consists of a control unit, a solenoid, and mechanical linkage. Using pulses from the ignition coil, the control unit detects engine RPM and switches the current supplied to the solenoid on or off to activate the valves through the mechanical linkage. An oil injection system is incorporated to lubricate the crankshaft of the cylinder. Located under the engine and driven by the crankshaft, a plunger-type oil pump delivers 2-stroke oil to each intake manifold. To regulate oil supply according to the throttle opening, the plunger stroke is controlled by wire linkage connected to the throttle drum. Primary gears, clutch, and transmission gears are splash lubricated by oil in the gearbox like most other 2-stroke engines. To ensure performance under long-term operation, a water cooling system is a must for high-performance 2-stroke engines. Using a water pump located under the engine, coolant is circulated through the cylinders, cylinder heads, thermostat, radiator, and back to the pump. To increase cooling efficiency during low-speed operation, a small electric cooling fan is mounted on the right-hand side of the radiator. For riding comfort, the engine is rubber-mounted in the aluminum frame to insulate vibration. A torque link is provided near the drive sprocket to prevent the engine from being moved rearward by the force of the drive chain. With all of the features explained so far, this engine turns out an incomparable 72 horsepower at 9,500 RPM with a mere 387 cubic centimeters of displacement. The last but not the least important feature of the NS400R is the new battery. This is a recently developed, fully sealed, maintenance-free battery required Before checking the oil level, start the engine and run at idle speed for a few minutes. Transmission oil level can be checked through the sight glass provided in the right-hand side cover. The motorcycle must be upright and both wheels on level ground. Never check or add oil with the motorcycle on the side stand. Excessive transmission oil will cause difficult clutch disengagement, while, if the oil level is too low, damage to the transmission gears may result. Fill oil through this filler cap if necessary. In seeking the ultimate in motorcycle performance, the heavy, space-consuming main stand was removed from the NS400R. For long-term storage and maintenance purposes, a special motorcycle stand commonly used for racers is provided as a standard accessory. Let's look at how the stand is used. It is designed to allow operation by one person. First, place the stand under the motorcycle in front of the rear wheel. Fit the stand under the location grooves provided at the bottom of the swing arm. Now, move the handle down to hoist the motorcycle up until it rests securely on the stand. To remove the stand, reverse the procedure. When you need to remove the side covers, first remove the seat and seat cowl using the ignition key. Now, remove the side cover retainer screw and pull the top front portion of the cover off the front mount. Pull the cover to the rear to unhook the rear mount. in this film we use an unmounted engine to show the details of the work clearly, the ATAC system can be serviced with the engine in the frame. First, remove the linkage cover and the chamber cover. When the solenoid is not energized, the valve is open. It is normal if the valve deviates approximately 15 degrees from the center position. To check the solenoid, directly apply 12-volt battery voltage and check that the valve closes fully when the solenoid is energized. Do not apply battery voltage for more than 3 minutes, or the solenoid coil may overheat. With the solenoid energized, check the clearance between the overstroke arm and link arm A. Clearance of less than 1 millimeter is normal. If clearance is excessive, the valve may erroneously become open while operating. At the same time, check that there is a clearance of less than 0.3 millimeter between link arm B and the housing. If clearance is incorrect, or the valve does not close completely when the solenoid is energized, adjust using the adjuster and recheck the clearance. To adjust the oil pump control cable, the lower expansion chambers must be removed. Now remove the oil pump cover. Operate the throttle and check that the oil pump control lever and the throttle drum start synchronously from the fully closed throttle position. Adjust if necessary using the adjuster. Cylinders and pistons are provided with ID marks A, B, or C for selection fitting to maintain the piston to cylinder clearance within the minimum allowable tolerance. Always use a piston and a cylinder with the same ID marks. When replacing a piston with a new one, check the cylinder ID mark provided at the bottom of the exhaust port and replace with a new piston having the same mark. Note that the piston ring set is common to all 3 kinds of pistons. With an ordinary battery, supplying charging current after the battery has been fully charged electrochemically decomposes water and the electrolyte into oxygen and hydrogen gases. These gases escape from the battery, causing loss of electrolyte, thus requiring periodic battery maintenance, such as replenishing with pure water. With the MF battery, pole plates are designed to prevent the negative plates from becoming full charged, even after the positive plates are fully charged. Because of this construction, only oxygen gas is given off from the positive pole, and no hydrogen gas is generated even when overcharged. The oxygen gas is then absorbed by the negative plates and reverted to electrolyte. There is no loss of water, and this fully sealed battery can thus be used without maintenance. Grids in the battery are made of lead-calcium alloy to reduce internal discharge. The space between the pole plates is stuffed with fiberglass to absorb and retain the electrolyte while securing the pole plates. Absence of free liquid in the battery eliminates electrolyte leakage problems, making the battery advantageous for motorcycles. The MF battery is always supplied together with a specially prepared and packed electrolyte. The specific gravity of this electrolyte is higher than that of an ordinary battery. The volume of electrolyte in each battery cell is also exactly prescribed. To assure full performance, use only the prescribed electrolyte. Never use ordinary electrolyte. prepare this battery for use, first remove the aluminum seal. Since the MF battery is a pre-charged instant activation type, do not remove the seal before use. Cut open the nozzles of the electrolyte container. Fit the electrolyte container to the battery. Now, cut open the air vents for each cell. Allow the electrolyte to drain and permeate the battery for approximately 10 minutes. Remove the electrolyte container and fit the sealing plugs. Press the sealing plugs firmly in until the tops of the plugs are flush with or lower than the battery top. The battery is now ready for use. As the MF battery is fully sealed and there is no free liquid electrolyte, it is impossible to check the charging condition by measuring the specific gravity of the electrolyte. The charging condition must be checked by measuring terminal voltage using an accurate digital voltmeter. If terminal voltage is above 13 volts, the battery is full. If it is below 12.3 volts, the battery is low and requires charging. When carrying out charging, be sure to follow the charging instructions given on the top of the battery. Excessive charging current or duration will impair the life of the battery. Do not pry open the sealing plugs when carrying out charging. Even when excessively charged, pressure cannot build up in the battery because of a built-in safety valve. When checking the charging condition by measuring battery voltage, it should be noted that the battery voltage drops gradually after charging and becomes steady after about 30 minutes. Let's review the important points. Use only the electrolyte supplied together with the battery and fill all the electrolyte into the battery. Follow the charging instructions given on the top of the battery. Do not remove the sealing plugs.